So we're in 4.6 now, and we're going to graph secant and cosecant functions. Not in this class. So we're going to graph secant and cosecant. So I'm going to give us a list of steps for graphing secant and cosecant functions. We know that the secant function is related to which trig function? Cosine, and the cosecant is related to sine. So we're going to refer to the sine function and the cosine function as the parent functions. So secant is related to cosine, secant of an angle is related to cosine of an angle, cosecant is related to sine of the angle. We're going to call those the parent functions. So when we're graphing secant and cosecant functions, we're going to talk about the parent functions. So to graph them? Our first step is to write and then graph the parent function. So for example, we'll do an example. If we had y equals 2 cosecant x over 2, I'm going to rewrite this. I want to write plus graph y equals 2 sine x over 2. So this is what I mean by write and graph. So I want to rewrite our function just looking at the parent function, and then I'm going to graph this parent function. So we already have all the steps, everything we need to know to graph this parent function. We know how to graph sine functions, we know how to graph cosine functions. Our second step, because our cofunctions are reciprocal functions, everywhere the parent function is 0, we're going to have an asymptote because we'll be dividing by 0. So everywhere the parent function is 0, the secant or the cosecant, the cofunction is going to have an asymptote. So we're going to graph asymptotes, and we're graphing vertical asymptotes. Where the parent function equals 0. And the reason we're doing that again is because the cofunctions are reciprocal functions. So if we have the parent function equals 0, we're dividing by 0. So we get a vertical asymptote. Our third step is we need to figure out the minimum and maximum. The cofunction has a minimum where the parent function has a maximum. And the cofunction has a maximum where the parent function is a minimum. I'll put that as a separate step here. And finally, we sketch our graph. So we can graph the minimum and maximum of our cofunction, and then we just sketch our graph between the asymptotes. So those are our steps for graphing the cofunction. The main thing that we do is graph the parent function first. Yeah.
Just remind me what an asymptote is.
Asymptote is like if we had some function and our asymptote, so our function goes like that and never touches the asymptote. Or if it's going down, it goes down but never touches the asymptote. Okay? So our first step is always for the secant and cosecant functions to write and graph our parent function first, sketch the asymptotes, so graph our vertical asymptotes where the parent function is 0, and then we can find our maximums and minimums of our cofunctions, and then sketch our graph between the asymptotes. So let's look at an example of this. So the one we wrote before was y equals 2 cosecant of x over 2. So not much happening with this function, so we don't have to fiddle with all the changes. So we can concentrate on just graphing the cofunction. So I'm going to rewrite this as y equals 2 sine x over 2. We already decided that. So let's pick out our numbers. Our amplitude A is 2. B is going to be what for this function? 1/2. So the period is 2 pi over 1/2, which equals what? 4 pi. Yes. So when we're graphing, we don't want to switch anything. We just want to, instead of writing cosecant, we're just going to write sine. So we don't have to switch anything. So we're not, you're thinking that it's a reciprocal function, so we should be flipping something. But for graphing, all we're doing is changing this cosecant into a sine. So just to graph that. That's a very good question. All right, so our period is 4 pi, and we're going to, our period, our interesting points, we're going to divide the period by 4. So we're going to look at every pi units. We're going to start our graph where x over 2 equals 0, or x equals 0. And we're going to end one period where x over 2 equals 2 pi, and we could guess, because we're not shifting, since our period is 4 pi, we're going to end where x equals 4 pi. Since we're not shifting left and right, we can just go from 0 to 4 pi. So here's going to be my sketch, and your sketch doesn't have to be beautiful and perfect, because I know mine sure aren't. We're going to start at 0, and we're going to move by pi units over to 4 pi. So I start here at 0. I'm going to go here to pi. I'm going by pi units. So there's 2 pi, 3 pi, 4 pi. I'll go some more so we can graph more than one period. We're moving over by pi units, so 5 pi, 6 pi. I'll stop at 7 pi. I think we'll get the picture by then. And I know that my amplitude is 2, so I have to go up here and down here by 2 units. So here's 2 and here's -2. So now we're ready to start graphing. The sine function, where does sine start? At 0. If I'm at x equals 0, sine starts at 0. I'll put that in red. And if I plug in pi here, where's pi going to go, or where's sine going to go to? Goes from 0 up to its maximum. And I can also check this point. If I plugged x equals pi in here, I would get sine of pi over 2. From my unit circle, sine of pi over 2 is 1, multiplied by 2, and I'm up here at 2. So from a maximum, it goes back down to its minimum. I'm not to its minimum, to 0. Back to 0. From 0, it's going to go where? To negative 2. So at 3 pi, I'll be down here at negative 2. At 4 pi, where am I going to go? Back up to 0. And this is one, I've done one period here. So here's my graph of my parent function. And then at 5 pi, we're going to start repeating. So at 5 pi, it's going to go back up here. 6 pi, I'll be back down to 0. And at 7 pi, I'll be back down here at negative 2. So this is a rough sketch of my graph. This is plenty of detail. I have my x values. I have specific points plotted. Now, my steps say I graph the parent function. Now I'm going to draw an asymptote everywhere the parent function is 0. So on our graph, where is the parent function 0? What's that? 0, 4 pi. Everywhere it crosses the x-axis, right? Our parent function is 0 everywhere it crosses the x-axis. So we're going to draw a vertical asymptote everywhere our graph crosses the x-axis. That's where our graph is 0. So there are my asymptotes. So my cosecant function, my next step says it has a minimum where the parent function has a maximum. Well, here's a maximum, and here's a maximum. Our steps say it has a minimum, a maximum where the parent function has a minimum. So here's a minimum, and down here is a minimum also. And then our last step says sketch the graph between the asymptotes. So from here, my graph is going to go up like this, and up like this. From here, it's going to go down like this. And then it repeats. This is going to go up like this. And we'll go down. And if I continued. So there's my cosecant function. And my parent function is in red. So I graphed the parent function, found the asymptotes, and found the maximums and minimums, and sketched my graph between the asymptotes. Questions on that? So we've already learned the hard part. We've already learned about graphing sines and cosines. That's 3/4 of graphing cosecants and secant functions. And we just have to sketch in our asymptotes and draw a point for our maximum, minimum, and connect our graphs between the asymptotes. The secant function looks very similar to this one, except the secant is shifted a little bit from a cosecant function. So it'll look the same way. We'll graph it the same way. It just our parent function the graph will be just a slightly different shape, but the steps and the procedure are exactly the same. Any questions on that? Yes, question?
How do you know that you draw the vertical asymptote everywhere it crosses 0?
Well, that's a good question. So we said that at the very beginning, we said that that the cosecant of theta is 1 over sine of theta. So the question was, how do we know that we draw an asymptote everywhere that this crosses the x-axis? So the cosecant of theta is going to be undefined. Anytime I divide, because it's reciprocal, anytime I divide by 0. So this is undefined when sine theta equals 0. So that makes me divide, that turns this fraction into 1 over 0, so that's undefined. So on my graph, my parent function is 0, y equals 0, everywhere it's crossing the x-axis. On the x-axis, y equals 0. So when my parent function, the sine function, is crossing the x-axis, that means the sine of this angle, whatever this thing is 0 there. So everywhere across the x-axis, I would be dividing by 0 to get my cosecant. So that makes it, the cosecant is undefined. And when I'm graphing a function that's undefined, where it's undefined gives me an asymptote. Okay? Any other questions? All right. Short notes today. Long examples for homework. So we're on page 318. There you go.